we're going to continue, kind of wrap up those 2.1 notes and the idea of a formal definition of a derivative. So we are going to use f of x as x over 4, I'm sorry, 4 over x, and then find our derivative at negative 2. Okay, so I'm going to kind of write this down for myself. You want to take the question, put it in your own words or what you're doing to make sure you understand. I'm going to go back and do, all right, what's that formal definition of a derivative? That is the limit as h goes to 0 of f of a plus h minus f of a, and that is all over an h. Okay? All right, so I go and I'm like, all right, I've got this function. Here's where I want my derivative. So that a is really negative 2. So limit f, so negative 2 plus h minus f of negative 2 all over h as h goes to 0. All right, that's what I'm looking for. So now function notation says take f and plug these values in. So I'm going to plug those values in with h. So I am going to have 4 over negative 2 plus h minus 4 over negative 2. So a little different. Yesterday we did a whole bunch with quadratics, and you were formulating and all that kind of stuff. This is a little different because now we're subtracting some fractions in here. Okay, so we start simplifying. Don't forget the h, the limit, the h going to 0. I know it's tempting to just start doing a bunch of math over here and simplifying, but you are showing the formal definition of a derivative, and it's kind of like a proof, like an algebra proof of these are my steps and this is what I'm doing. Okay, so really if I simplify my fractions, that one would stay. This would be like a plus 2 because 4 over negative 2 is negative 2, and then 2 negatives make it a plus. Now in order to add a fraction to a whole number, I must have that common denominator. So in order to get a common denominator, I am going to multiply my 2 by that denominator over itself. So it's like a version of 1 that contains that denominator. So then I'm getting over h. Keep these separate for a little bit here so you can see my steps. So I would have negative 4 plus 2h. So distribute that in. Okay, distribute that 2 in. So I got that. Now that I have my common denominator, I can put them together. H go to 0, h. So I would have 4 plus 4, which is going to 0 out. So I would have 2h over negative 2 plus h, and then that is over h. Now, you have to have correct algebra. You can't just start crossing off h's. So you will remember from our pre-calc days, hopefully, or after this you will, that I can, instead of dividing by a number, or in this case, if I'm going to make it a fraction, I can multiply by the reciprocal. So dividing by h is the same as multiplying by 1 over h. Now those h's divide to 1, or cancel if you will. So now I have h going to 0 of 2 over negative 2 plus h. So notice this 2, these are multiplying. These two h's divide by 1, that 2 is still there, and then times 1, which would just be that, and then your denominator. Now that we have canceled this divide by h that was around from where we started, now I can evaluate my limit by plugging 0 in, and I have negative 2 plus 0, so I would get negative 1. And again, that means that f prime at negative 2 is negative 1. The slope of 4 over x at negative 2 is negative 1. And so it's, again, that formal way of deriving it versus just plugging in some numbers and hoping we kind of estimate correctly. Now we have a process for getting that number. All right, let's do one with an application. So we have suppose that d of t equals 10t plus 15t squared is the distance in miles that a car travels west over a certain number of hours. Use the definition of a derivative to find the exact speed of the car at time 3. Okay, so that sentence right there means what is d prime of 3. Okay, so it wants us to use that formal definition of a derivative, so we have to go through this process again. So we have the limit of h going to 0 of, I'm going to write it out first. I'm going to start with the d. I know my function name. I know we use f when we start introducing it, but I know it's d now, so I'm going to say d of a plus h minus d of a all over h. Okay. I would suggest pause the video right now, see if you can go through the process of plugging in a, simplifying algebraically, and working it down. When you feel like you have it or you got stuck, hit play, and then you can hear me go through it. All right, so I'm going to plug in 3 here. I'm going to kind of start over here so that I have room. H go to 0. That is important to be there, like I said in the last question. 3 plus h, d of 3. Okay, function notation, plug those in. Now, in this case, I am plugging them into both t's. So I'm going to have 10, 3 plus h, plus 15, 3 plus h, minus, and then I've got to subtract this whole quantity. So now I want 10 times 3 plus 15 times 3 squared. Okay, and that's going to be a difference now. You kind of have a little bit bigger and you have multiple terms, but it still is the same process. You just have a little more algebra. I forgot a square right here. My apologies. All right, so start simplifying. So I still have my limit. I'm still going to 0. So I would have 30 plus 10h plus, okay, now I'm going to FOIL this together. So I'd have 9 plus 6h plus h squared minus, and that thing is 165. You calculate that out. Okay, I'm going to distribute my 15 in, so limit h 0. Sorry, those are a little bit sloppy. Okay, so if I do some combining here, I would have, I'm going to kind of distribute in, so I would get a 15h squared. I would have a 90h and then 10 more, so I'd have 100h. Now if I do 30 and then 15 times 9 minus 165, that actually is 0, so it's 165 minus 165, so I would just have that. Now you cannot cancel anything right now. The only time things cancel in a fraction is when it's factored and you have two factors that are the same and then they divide to 1. So you must go to here, take out that h, 100 or h. Now they factor out and cancel. So now I have the limit as h goes to 0 of 15h plus 100. Sorry, that's 0. And then now I can plug in my 0 or evaluate my limit, plus 100. So you are going 100, and this would be miles per hour based on the directions that were up there. So your time at exactly 3 hours is 100 miles per hour. All right, your next task today then is to go do, so if you were in class, you got a yellow, it's called the Formal Definition of a Derivative 2.1 worksheet. If you are one of my distance learners, it is attached for today's lesson. It's a worksheet that's 2 pages. So I'm going to go over a problem on each side just to kind of help you get going. So on the front side, I'm going to go over number 5, which says to evaluate this. Your limit is h goes to 0 of g of 3 plus h minus 4 over h. Now notice above question 3, so here's question 3, there's this whole bunch of information about g, and then there's like 7 things listed up there. So 5 says to evaluate this. I don't have to evaluate like I just did those last 2 because I don't have an equation. Plus, the directions do not say use the formal definition of a derivative to evaluate. It doesn't have that. Okay, this is more of a notational recognition of what does this mean. And that's the challenge in these questions. Your key or your hint that this is going to be some type of slope is that you have h going to 0 and you are dividing by h. You also have, I'm going to say delta g, but you have some kind of change in up here. Here's change like 1g value, which is a y, and 4 might be a y value. So there's a good chance this means what is the slope. And so I'm going to check my notation. So here is g of 3 plus h. If this was that formal definition, this value should be g of 3. And so I look up here in my directions and I see like the second thing says g of 3 equals 4. So really I could rewrite this. You don't have to rewrite this, you just need to recognize this. I'm going to show you that. So this is g of 3 all over h, and h going to 0. Well, this is your setup for your formal definition of a derivative, which means it is asking you what is g prime of 3. Okay, again, this notation, you have your difference quotient. You're sending the difference between your two x values to 0. And so this is your formal definition of a derivative. I don't have a function. I'm not going to do the algebra where I plug in and simplify and cancel. And I just want to know what's the slope at 3. And when I look back up here, it says g prime of 3 is 5. So this question is 5. Okay, try the other ones around it. Hopefully that kind of helps you get you started. On this paper, the whole paper, the front and the back, you are not doing this process on this paper. It is a notational recognition of this means derivative and then what is your derivative. Okay, now on the back, I'm going to get a new slide here. So on the back, it says AP Calculus definition of derivative worksheet. I am going to do number 7, which says this. Your limit as x goes to 3 of x minus 3, x cubed plus x minus 30. Okay. Now, the directions want to know what function and at what point. So this is similar to what we did in notes yesterday. What's your function and what is your a value? We're not actually doing these ones either. Like, we're not evaluating them. We're finding it. We're just recognizing our parts. So I look and I'm like, okay, this isn't the h going to 0. I don't have an h down here. I'm not going to 0. I have an x going to 3, and I have a 3 minus x on the bottom, which this was kind of in that list from page 86. It was kind of the second one. And so this is your a value. So we're going to that. Now the challenge is up here of what is your function, which part's the function and which part is not, because your format is supposed to be this, x minus a, limit x go to a. Okay? So your key here is this subtraction symbol. Sometimes if you're subtracting a negative, it gets confusing, but this minus 30, that's part of your difference quotient. So that we're hoping should be f of 3, which would mean this first part, x cubed plus x, should be your function. And I can check it by saying, all right, what's 3 cubed plus 3? Well, that's 27 plus 3, and that's 30. And so that's where that 30 came from. And this question is more challenging than some of the ones we started with yesterday, because you have multiple parts or you have two things adding as your function. And so sometimes it's not as easy to see that this is the formal definition of a derivative. One thing that really tips it off, though, is, again, when you plug 3 in, you get a divide by 0. And that doesn't necessarily mean it's undefined and you can't do it. That just means it probably or potentially is the formal definition of a derivative. And so really we don't have to like do all of this. We can figure out what's our function, where are we doing it, and go from there. Okay. Now for this whole side, you have questions 1 through 10. Again, we just did 7, but this is what I am looking for, or what we are looking for all of those questions. What's your function? What's your a value? Try every one. Take a good educated guess. We want you to come back to class tomorrow so we can go through and see how you're doing. If you're right, blank doesn't help us see where you are and what you're thinking. Okay? This worksheet should not take super long. It should be a couple minutes on each side, maybe thinking through. If you get stuck on one, try it again the next, a couple hours later or something. But after this, make sure you had some assignments for, let's see, you had page 110, page 111, and then page 88 was assigned yesterday. Go work on those, submit them as you get them done. If you were missing homework from other sections, they can, be turned in for up to 2 weeks late, and retakes can be done. So please use today, because we don't have a lot of notes, to get some stuff done and be prepared. Good luck.